In this video, we're going to take a look at the organs of the lymphatic system. So let's just hop right in. So the lymph nodes, we discussed them in the previous video just a little bit. These are very small, something on the order of 2.5 centimeters, little organs shaped like beans, kind of have a beanie kind of, sort of like that. They are covered by a fibrous connective tissue capsule. And here is a great video or image of a lymph node exposed in situ, so you can see all of its, all the lymphatic vessels that are leading into this lymph node. And they're found in clusters or chains in the pathways of the larger lymphatic vessels. And here we can see in this X-ray they've used something that will illuminate the lymph nodes, something radioactive that will illuminate the lymph nodes in this X-ray, and you can get a good view of where they're located here in the pathways of these. And so here you can see all the little lymphatic pathways, and these are the nodes then there in those pathways. And they function to filter out of the lymph any potentially harmful particles that may be found there. So they act as filters, and while they're filtering, we have lymphatic cells, so lymphocytes and macrophages, that will monitor the lymph, looking for non-self antigens, for any markers on the membranes of the materials that are passing through, or any proteins that the lymphatic system can recognize as not belonging within the body. So immune surveillance is the other, so they clean lymph, and they also perform immune surveillance on the body. So how does the lymph flow through a lymph node? So we have several afferent vessels, and if you remember from back when we talked about the nervous system, afferent is a pathway that brings something toward the point of reference, and so afferent pathways bring lymph to the lymph node. Efferent vessels bring lymph or carry lymph from the node. So we have multiple afferent pathways or vessels that bring fluid, lymph, into a lymph node, but only one vessel that carries the fluid away from the lymph node. And so this has the effect of, well, the same thing that happens when there's a whole bunch of roads that are bringing cars toward downtown, but only one road that will carry cars away from downtown. It creates lots and lots of congestion that slows the flow of lymph, which is great because we want that in a lymph node, because within the lymph node we have lymph sinuses. These are kind of areas where it's easier for the lymph to flow, but amongst the sinuses we have these clusters of lymphatic tissue called lymph nodules. And so as we slow the flow of lymph passing through this lymph node, we get lots and lots of time for the cells of the lymph nodules to interact with the fluids. So these lymph nodules are masses of macrophages. So recall, these are the white blood cells that do lots of phagocytosis, and lymphocytes. These are the white blood cells that are of the immune system. And so the macrophages are really good. They can remove up to more than 99% of any antigens that are found in the lymph. And then, in a process that we'll talk about in some coming videos, then the macrophages will carry the antigens they find to the lymphocytes and stimulate them to trigger the immune response. So the macrophages will digest these antigen-bearing particles and then take the antigens and show them off to the lymphocytes and get the lymphocytes all excited about removing them from the body. So lymph nodules are not just found in lymph nodes, but they're also found unencapsulated in a variety of locations that are referred to as MALT, the mucosa associated lymphoid tissues. So these are the lymphoid tissues that are found with mucous membranes. So the tonsils, there are 5 different ones of them. You can see these two, the pharyngeal tonsils, very, very nicely. The adenoids are also tonsils, and so we've got 5 different tonsils associated with the throat, with the pharyngeal region. The pyre patches are lymph nodules that are associated with the wall of the small intestine, and these are pyre patches here. So this is the intestine. We have a slice through the intestine. These are the villi that line the intestine. We haven't talked about that yet, but these are little extensions of the cell membranes of the cells. I'm sorry, not microvilli, but villi. These are folds. That's what I meant to say. These are folds of the intestinal lining. But here on the posterior wall of the intestine, there are the pyre patches, which are going to be busy noticing if any antigens or antigen-bearing particles are found in the food we eat. The appendix is right here at the joint between where the small intestine dumps into the large intestine, and so it is also busy keeping track of any immune triggering cells or materials that are found in food. And then kind of sprinkled generally through the mucosa of the rest of the digestive system, the respiratory system, the urinary and reproductive systems, we find other of these lymph nodules. So we've got them kind of all over the place. Any location where materials are entering the body, we're going to have lymph nodules, but especially in the throat and associated with the digestive system. So as we're breathing in and as we're consuming food, we're going to see immune surveillance with lymph nodules. Other organs of the lymphatic system include the thymus. It's found in the mediastinum, just posterior to the sternum. And this is the location where T cells, T lymphocytes, are matured. So as these T lymphocytes are being made in the red bone marrow, they will migrate eventually to the thymus, and the thymus will secrete hormone-like materials, chemicals called thymosins, that will then direct the development and the maturation of these T cells. And then once the T cells are fully mature, they'll leave the thymus, they circulate in the blood, and they'll take up residence in lymph nodules that are found throughout the body, as well as other organs. Now notice, comparatively, in a baby or a child, the thymus is very large. As we age, the thymus does not grow at the same rate as the rest of the body, so it becomes relatively smaller, and it also will shrink over time. And so by the time we reach old age, the thymus is very small, and this can contribute to a little bit of why adults or older geriatric folk have a weakened immune system, because they're not directing and training and maturing the same number of T cells that a young person in their prime might be maturing and growing. The spleen is the very largest of the lymphatic organs. It's found below or inferior to the diaphragm and on the back side of the stomach, so posterior to the stomach. Has a function very similar to lymph nodes, but rather than filtering blood, rather than filtering lymph, the blood will filter. Let me try this again. The spleen, rather than filtering lymph, will filter blood, and so it cleans up the blood in much the same way that the lymph nodes are busy cleaning up the lymph. And so we have lymphatic nodules that are that have macrophages and residential lymphocytes, and as the macrophages are working the blood over and cleaning out anything that doesn't belong, then they will take and present to the lymphocytes the antigens they find, and so in this way we can also initiate immune responses and clean the blood of foreign materials that don't belong. Because the passageways for the blood are so cramped and twisting and turning, this is the place where red blood cells frequently will burst if they are aging and the membrane of the red blood cell is no longer sufficiently strong to encapsulate or to hold in everything. And so as the red blood cells are dying here in the spleen, then the macrophages clean them up as well. And there's a lot of iron storage that goes on here in order to recycle that iron and get it back into new red blood cells.